This is the practice quiz, and we're just going to review some of the concepts on this. So the first question here says, find the domain and the range of this graph. Well, as you can see, this graph is continuing, and I'm going to emphasize that it would just keep going, which I tried to give you in number 1 up there in the directions. Given the following equation that repeats as shown and continues to repeat. So essentially, the x's are going to go on forever to keep going. So the domain of this function, since it goes on forever to the left and the right in the x direction, is going to be negative infinity to infinity. And the range, you can see that this is oscillating between the number -1 and 1. And so the range of this function is going to include, because it touches those points, it touches 1 up here and it touches -1 there, -1 to 1 is the range. For number 2 through 5, it says use these functions, and that just means use those functions to answer 2 through 5. So for example, f of 16, well, we'll plug 16 into the f function. Square root of 16 minus 7, square root of 9 is 3. That would be the answer. Number 3, 3 plus g of 5, which would be 3 plus, and we'll plug 5 into the g function, 5 over 5 minus 4, which is equal to 3 plus 5 over 1, which is equal to 8. So that's the answer. Number 4, determine the domain and range of h of x. Write in interval form. Well, if we look at h of x is 4x plus 3. That's a line, that's linear. All lines that are just written in mx plus b form, all linear functions, have a domain of negative infinity to infinity and a range of negative infinity to infinity. They're continuous and they extend in both directions. And number 5, determine the domain of f of x and g of x. Write in interval notation. Now, I didn't ask you for the range of these because I'm not giving you a graphing calculator, so I just am asking you to solve for the domain. So I will go to the next slide to finish this one. This is just a little cleaner. We're just doing number 5 on this slide. So if we look at f of x, which is equal to the square root of x minus 7, in order to have x be part of the domain, it cannot give you an imaginary number. It has to have a real number for the y value. So what we do on these square roots, remember, we take what's under the square root and we have to set that greater than or equal to 0. So in this case, x has to be greater than or equal to 7, and so the answer for this notation is 7 with a bracket, comma, infinity with a parentheses. All numbers from 7 and up solve this. For g of x, we'll take g of x, we're trying to find the domain of that. If we have g of x is equal to 5 over x minus 4, well, this is a rational function, a rational expression. That means that the bottom of that cannot be part of the domain. So x minus 4 cannot equal the bottom of that. When the bottom of that is 0, when the denominator is 0, that value of x is out of the domain. So x cannot equal 4. We take the denominator of the fraction and we set it equal to 0, and that's how we figure out our domain. Now if x can't equal 4, it means x can be everything else. So it can go to 4, don't include it, and then it can go from 4 to infinity. So it can go from negative infinity to 4 in union with 4 to infinity. So that would be the answer for the domain of g of x. Negative infinity to 4, union with 4 to infinity, and parentheses on both. Okay, these are review from the first day. F of x equals 3x plus 4, that's a linear function. G of x equals x minus 3 squared minus 2, this is a quadratic function. It would look like a parabola. Now it says graph them both, and so I'll put a new slide in and well, actually I think I could fit it here. So you'll have graph paper on the test, but you're going to look for your intercept for your linear. So for f of x, we'd go up 4, and that would be your intercept. And then your slope would be 3, so you would go up 3 over 1 or down 3 to the left 1. Okay, and of course on graph paper you'll be able to do it better. So there's your graph. And the intercept, of course, here we would have 0, 4. That's one intercept. And on the other place here, you would have an intercept of -4/3, 0. If you plugged in when y is 0, so to find your other intercept, if this is 0, when y is 0, you can solve for x, and x would be -4/3. Okay, now graphing the parabola, I'll put the parabola over here. Put the parabola over here. The vertex of this parabola is 3, -2, so we're going to go over 1, 2, 3, -2. And again, you'll have graph paper you're doing this on. And then anytime, once you know the vertex, you're going to go 1 to the left and 2 to the left, or 1 to the right and 2 to the right. So if I say, what if x is 4? Well, 4 minus 3 squared minus 2. Right, so g of 4. And that's going to be 1 squared minus 2, so minus 1. So when I go over to 4, I'm going to be at -1. And when I go to 2, I'll be at -1 because it's symmetric. And then we could also do g of 5. So let's say g of 5. It's going to be 5 minus 3 squared minus 2. 5 minus 3 is 2. 2 squared is 4. 4 minus 2 is 2. So when I get to 5, I'm up at 2. That means I must be 2 here. And there's your function. For this piecewise function, we know that it's piecewise at 2. So when x is 2, that's when this function changes. So I'm going to draw in the first part, the absolute value. The absolute value of x is going to look like this, and that's only true when x is greater than 2. And so I'm going to erase the bottom of this, right? And we're going to put an open circle on this function at 2, 2. And there's your absolute value. It starts with an open circle at 2, 2. So that's this part of the function. Now, the second part of the function is x squared when x is less than or equal to 2. So I'm just going to make a table. So if x and x squared, okay, which is the f of x, right? So if we start at 2, and we're going to go backwards, 1, 0. So when x is 2, x squared is 4. When x is 1, x squared is 1. When x is 0, right? So this is a regular, the very standard parabola, and it starts at 2, 4. So 1, 2, 3, 4. And it has a closed circle there. And at 1, it's at 1. And at 0, it's at 0. And so this parabola is doing this. And so this is a jump discontinuity. So it is not continuous. And this is a jump discontinuity because at x equals 2, the function, you would have to lift your pen and jump from 2, 4 down to 2, 2. You'd have to jump this distance here. Now in terms of local minima, there is a local minima here. And we would say that f of 0 is equal to 0. The y value is the minima. That's a local minimum, the y value. On this line of best fit, I've plotted the data, and I'm drawing a straight line through the data, which you'll see on the next page. The key thing here is the line was drawn with a ruler, so that's important. And then I've circled the 2 points, and you can see that at 5:18, it goes right through the corner of that grid paper. So the 2 points that I'm going to use to find the equation of my line are 5, 18, and I think it goes through the data point 621 very well. So the equation of that best fit line, we know an equation of a line should equal y equals mx plus b. I'm going to find the slope first. So slope, y2 minus y1 over x2 minus x1. So when I plug in my y2 and my y1, I get 21 minus 18 over 6 minus 5, so I get a slope of 3. So now I'm going to plug that slope of 3 back into my equation and use one of my points. So I'm going to take my point 5, 8, well actually I'm going to take my point 6, 21, just because I know that it doesn't matter which one. So if I take y equals 3x plus b, and I'm going to plug 621 in here. 21 equals 3 times 6 plus b, and you'll find that 21 equals 18 plus b, so b equals 3. So the equation of my best fit line is y equals 3x plus 3. That's it.